students, we are back for another session of Mathematics 10 with me, your teacher, Mr. Pineda. This is a video about deriving arithmetic sequence formula, and without further ado, let us start with the lesson. Deriving arithmetic sequence formula. So the formula for the arithmetic sequence is also known as the nth term formula. So let us consider this arithmetic sequence 7, 4, 1, negative 2, and so on until a sub n. So deriving the formula for the arithmetic sequence, which is also known as the nth term, requires us to write each of this term in this arithmetic sequence in terms of the a sub 1. So in this case, our a sub 1 is 7. But before we do that, let us have these terms written first. A sub 1, a sub 2, a sub 3, a sub 4 until the a sub n. So here our a sub 1 is the 7, while our a sub 2 is actually 4. But like what I have told you, we would like to have each of this term be written in terms of 7. So for our a sub 2, it will now be written as 7 plus the negative 3. So we could have this expression be written as 7 minus 3, but you have learned in the previous lesson that we are actually performing an addition in an arithmetic sequence. So we better have this expression be shown in terms of the addition. Having this for our a sub 2, 7 plus the negative 3. While on our third term, we will have 7 plus the negative 3 plus another negative 3. So remember that this expression right here for a sub 2 is actually a 4, and we also have this 4 right here, and adding another negative 3 gives us a positive 1. So for our a sub 4, it will now be written as 7 plus negative 3 plus another negative 3. So remember that this is actually our positive 1 right here. And by adding another common difference of negative 3, we will have the value for the fourth term, which is negative 2. Since we do not know specifically what is the nth term for this sequence, then let us have this be written as a sub n. And to continue with the derivation process, let us have each of this expression be simplified. So having this to be obviously just a 7, while here we have 7 plus negative 3. While for our third term, so remember when we are adding numbers like this is actually a multiplication. So having 2 of these negative 3's may be written in multiplication as 2 times negative 3. While for our fourth term, since we have 3 negative 3's, then we may have this be simplified by writing 3 times negative 3. So again, this will just be expressed as a sub n. And at this point, I would like you to focus on the subscripts, for which if we focus on this subscript 3, you may notice a certain pattern that exists with this 3 with this number here, which is positive 2. And you may also notice that the same pattern applies to this subscript and this particular number 3. So for which, if we would like to have this 2 be written in terms of 3, then we may have this to be 3 minus 1. So 3 minus 1 is actually A2. So yeah, simply remember that we will only reduce this number by 1 and we will come up with this number 2. And that same pattern applies with the 4 right here. So if we would like to have the 3 be written in terms of 4, then we will have 4 minus 1, which is obviously equal to 3. So with that, let us see if those patterns are actually the same with the previous terms. Like for a sub 2, you have already noticed that the numerical coefficient right here is 1, for which the same pattern applies. Like if we reduce the 2 by 1, we will have this exact value of 1 right here. So the same pattern applies for the second term. But for the first term, we have a 1 right here, but we didn't see anything like this in this particular expression. But if I would like to show you exactly this expression, then we may have this 7 plus 0 times negative 3. So remember, 0 times negative 3 gives us 0, and adding a 0 to that 7 doesn't change that original value of 7. So that means the same pattern applies for this particular term, for which if we would like to have this 0 be written in terms of 1, then we will have this 1 minus 1 for us to have a 0. So notice that the same pattern applies for all of these terms, for which if this 1 is reduced by 1, it becomes a 0. When this 2 is reduced by 1, it becomes a 1. And 3 minus 1 gives us 2, while 4 minus 1 gives us 3. So that means we may have this be written as 7 plus. So remember that we are reducing the 1 by 1 so that it gives us the 0 a while ago. While here, we have this 2 minus 1 to give us the invisible 1 right here multiplied with negative 3. While for the third one, we have this. So remember, 3 minus 1 gives us the 2. And then we multiply this with negative 3. So same goes for the rest. So 4 minus 1 gives us 3. And writing this, we have negative 3. While this one remains the same. And let us proceed. So at this point, I would like to have this be written in terms of variables. Like for this 7, this actually corresponds to the first term. So changing all the 7s with a sub 1, and now let us take a look at this expression right here. So notice that the first numbers actually corresponds to the position of the term in the sequence. And you have learned in the previous lesson that this is actually the n. So again, n is relative to the position of the term. So if we are referring to the first term, then your n is equal to 1. So writing this one as n. Same goes for this, the second term. So your n is actually 2. While here in the third term, your n is equal to 3. While for the fourth term, your n is equal to 4. And writing all the remaining parts of this expression gives us n minus 1. And we have also learned in the previous lesson that this fixed number being added to the preceding number is what we call the common difference, which is written as d. So changing all the negative 3 with d gives us this resulting expression. And now, you may notice that all of these expressions now are the same for all of those terms. So that means your a sub n could be calculated using that same expression. So with that, your a sub 1 is given by this expression. Your a sub 2 is also given by this expression, and same goes for the a sub 3 and the a sub 4. So that means the a sub n will also be given by that same expression, a sub 1 plus the quantity of n minus 1 times d. And this will be our formula for the arithmetic sequence, which is also known as the nth term formula.